Alright, we got a 2015 Chevy Camaro here. Got a complaint of a check engine light, and also intermittently every once in a while there's a long or extended crank time. So let's check it out, see what we got. Alright, the data link connector on these, it's going to be right here. We're just going to take the Bluetooth module for the Autel and plug it in and go ahead and scan for codes. Alright, we'll go ahead and scan for codes, and of course, seeing as it's Bluetooth, we got the car with the key on over there, and we can just sit over here on the bench. And we'll just scan all the modules, see what we got. Alright, let's see what our fault is. Looks like we got a P0496 EVAP system flow during non-purge. Let's look at our freeze frame. See when this happened. Alright, looking at our freeze frame data, you can see we were in open loop. The engine coolant temperature was 73 degrees. And let's see. Engine speed 1300 RPMs. We were at 0 miles per hour. And engine runtime, so 10 seconds. So this happened, this ran its checks and failed right after it got started. You can see our desired idle was exactly the same. So yeah, it was a cold startup, and set the check engine light right away. Alright, real quick, a little background on what's going on here and what this issue is. This is an EVAP problem, and that's part of your emissions. And the EVAP system on most vehicles consists of a charcoal canister, and Chevys in general like to hide them in the back near the fuel tank. And then you have a vent solenoid in the back there, and then you have a purge solenoid up here in the front. That's attached to your engine vacuum. And basically the job of that charcoal canister in the back is to store all the fumes from the gasoline tank. So all the gasoline fumes get sucked into that charcoal canister and are held there instead of venting them out into the atmosphere. And then at specific intervals, the purge valve up there will open up. Normally it's closed, but the engine computer will command it open, and then the engine vacuum will suck those fumes into the engine and it'll burn them. So that way we're burning them up instead of sending them out in the atmosphere. Alright, so what does this P0496 mean? What's going on with the vehicle and how does it set? Well, the engine computer runs that test on a cold engine, which is why we saw this trouble code on a cold engine. And basically what it does is it seals the vent solenoid in the back, and it leaves the purge solenoid closed up front because it's normally closed, and it looks for changes in the fuel tank pressure sensor, which is in the back attached to your fuel tank. And what it doesn't want to see, or what it's looking for, is engine vacuum pulling a vacuum on that fuel tank pressure sensor. And so if it sees vacuum back there, it knows there's a problem with this purge valve, and then that's where we're getting the code from. Because on a normally operating system, when that's closed and that's closed, we should not see any engine vacuum back there on the fuel tank pressure sensor. So that pressure sensor should stay pretty well the same on a cold engine. We shouldn't see a lot of volatility. If it's a hot engine and you seal the system, you may see some changes, but on a cold engine you won't really see much change, which is why they do this on a cold engine. Alright, in order to check this, we're going to go into our engine computer here. We're going to go to active test. Come on. Let's see, EVAP. We're going to go to the EVAP system. We're going to do an EVAP purge seal. And what we want is that EVAP vent solenoid back there. We don't want it to be venting. So let's turn it to not venting. Come on. Alright, so our EVAP vent solenoid in the back is no longer venting. So it should be closed as long as it's operating properly. And our purge should be closed because we're at a 0 duty % cycle. So we're not commanding it on. And then what we're going to do is we're going to look at our fuel tank pressure. Actually, we'll look at our voltage. Where's our fuel tank voltage? Our fuel tank pressure voltage. We're going to start the engine, and after a minute or two we want to watch this fuel tank pressure and make sure it doesn't go above like 1.7 or so. If it does, that means we're pulling vacuum inside that tank, and we shouldn't be. And you can see our fuel tank pressure is going up. We're at 1.75, now we're at 1.8, and we should definitely be less than 1.7 on this. So we're definitely stuck partially open on that purge is most likely what it is. We'll have to check the circuit, make sure the commands are getting there properly, and if that's the case, we'll call a purge solenoid and get this thing fixed. And as we're sitting here, the engine just turned the evap solenoid command on, so right now we're at 13% duty cycle, and I could hear the engine stumbling, probably because it was looking for some fuel vapors and it wasn't getting any. It definitely stumbled as soon as that purge solenoid was commanded open. And another way we can check our to see if our vent in the back is working, our vent solenoid, we'll vent it, or I'm sorry, we'll seal it. We'll look at our fuel tank pressure. See the drastic change right there? We know that it's working because we got that drastic change right there. If it wasn't working, we wouldn't see any fluctuations. And when this system is running its checks and the system is sealed up, it doesn't want to see more than 10 inches of vacuum on this fuel tank pressure sensor for more than 5 seconds. If it does, that's what sets the check engine light. Alright, here's a shot of the engine compartment. This is a V6 that we're working on today. We got to take this cover off because the purge sits under there. So first thing we got to do, we'll pull the oil cap off and pull these covers off. And just pull that out. We should just be able to pop this off. We'll take this off. Alright, there's our purge valve right there. So we got to get this second cover off. We just got to get these little plastic clips off. We should be able to just pop them up out of there a little bit and we can get them off. So the centerpiece comes off, and then we can either just take the whole cover off or we can just pop these out also. So I'll get both of these off and we'll pop this off. There's the lower half. Whoops, don't drop it. You can just pull this off. This should not be loose. We'll have to put that back on. Put that back on so we don't drop anything in there. Alright, we're going to test this circuit real quick. So all I did, here's the plug to this purge valve. All I did, squeeze the bottom right there and pull it out. I'm going to put a test light on there. We're going to test this thing. Alright, as you can see, using my AES Wave test lead kit, I just have some adapters in there so that we can hook it up to the test light. And now we're going to command it on with our scan tool, see if our test light lights up. Alright, we're going to go in the same evap purge and seal test. Now what we're going to do, we're just going to command these percentages down here are our purge solenoid because it's a duty cycle controlled. You can just hit 10%. See if we got, there we go. And let's go up to like 40%. Should get a little brighter. There we go. There's nothing wrong with our circuit, nothing wrong with the computer or the driver. We got a bad purge solenoid, we need to get it fixed. Alright, here's a shot of the AES Wave test lead kit. I've shown this before in some of my videos. That's my test light. That doesn't belong in the kit. Alright, we got the new part to fix this vehicle. Got this one from AC Belco. Let's see, there's your part number right there. As you can see, it's the same as the GM part number. Made in Mexico. And that's what she looks like. So So now we just got to get the old one off. It's just a matter of disconnecting the line right here off that nipple right there, and then we got to unbolt it. Alright, to disconnect this line, we just need to press this tab over like that. See how now it's popped over this way? And then we should be able to pop this off. You can see, there we go, now it's off. Now we just gotta get this bolt off. Alright, it's a 10 millimeter, so we'll just take a 10 millimeter quarter inch, loosen it up. And as you can see, it takes a little force, but you just have to pop it out. You just have to overcome that O-ring right there. That's how easy it is to take off. And it's always a good idea, verify the parts before you install and make sure they're exactly the same. As you can see, even though it says AC Delco, it's really made by Bosch. Made in Mexico there. That's the old one. And you can see the new one we're putting in is exactly the same. Same exact thing from Bosch. Alright, let's get it installed. Alright, to get this thing installed, we'll just push it into place, past that O-ring, and then we'll get this bolt started. Alright, we don't want to draw this in with the bolt. This should just be tightening and securing it, but not pulling it in. So we want to make sure this is pressed all the way in, which you can see it is, and then we'll tighten this bolt down and get it plugged back in. We'll just get it snug. It's only a plastic fitting on a 10 millimeters fastener, so we don't need to kill it. And then you can see this is spring loaded, so we'll just press it over, get it all the way past it and make sure it springs back, and then we'll get our connector connected. And I should mention, I turned everything off after I was done testing it, turned the vehicle off so we don't have any more power to this thing. Alright, there we go, and you can see it's on a little rubber grommet, so it will move around a little bit. But we'll make sure it's tight again. But it has a shoulder in there, so it's only going to go so tight, and then that's it. So don't sit there cranking it thinking you're going to tighten this anymore. So yeah, as you can see, you can still move it around a little bit. That's natural. That's the way it's supposed to be. I put an extension on here so I can sneak around this fitting and show you. This thing, yeah, it's tight. We're not going to try to tighten it anymore. So if you see a little bit of play like that, it's just the rubber bushings right there. That's how it's designed. Alright, before we put the covers back on, we'll give it one more look over, make sure our bolt's tight, make sure this is on, make sure we're plugged all the way in, otherwise we'll get another check engine light. Now we should be good to go. Let's get these covers back on. Alright, this one just sits over the back. Just sits like that, right where these two holes are. And then we'll take our bottom piece, we'll snap that in first on each side, and then we'll take our center pieces and we'll press them in. They are kind of keyed, so we'll make sure we get them the right way. Make sure not to force them in the wrong way or you'll be buying new clips. Alright, now we'll take our oil cap off. We'll get this back on. Whoever did the oil change certainly didn't care about getting oil all over the place. Clean it up a little bit, that way all that garbage isn't falling down into the engine. It just clips under in the back right here on both sides. And then there's a grommet, snaps right into here. Then we can put our oil cap back on. Alright, as you can see, I put this piece of rubber trim back on like it's supposed to be. I wiped off the engine a little bit. Make it a little bit better than when we found it. We'll make sure to grab all our stuff. We don't leave anything under the hood. Alright, last thing we'll do is clear the codes. As you can see, we have our original code. Can you see that? Then we have a new code of P0443. That's from unplugging the solenoid and doing our test. That's just a circuit code for that purge solenoid. No big deal. We'll go ahead and clear them. That way the engine light will be off for the owner. We'll verify and make sure. Alright, no codes detected. We're good to go. Alright, little bonus footage. Let's see what it looks like. See, with us not venting, how our fuel tank pressure didn't go way up like it did before? Confirmed fix. And you can see with it not venting and the purge is off, you can see what our pressure is 1.5. Now we'll just do like a 30%. So we'll open that purge up and you can see how it goes up. So our purge was open just a little bit. It was leaking just a little bit, and that was causing the problem. Alright, for those of you who stuck around to the end, what do you do when you don't have a fancy schmancy scan tool to help you diagnose this stuff? And you know, one that you don't have one that can command these solenoids on and off or look at the data and things like that. Well, here's what I would do. I would unplug the solenoid with the vehicle running, knowing that in its natural state these purge solenoids are closed. So once we unplug it, there's no way for the computer to command this on. So then we know it should be closed. And obviously with it still on the vehicle, we're going to check for vacuum right here. You can use your finger and just go like this and see if you can feel it sucking your finger in. Or you can put a vacuum gauge. If you have a vacuum gauge, you can adapt a vacuum gauge on here and see if you have any manifold vacuum. Now this one was just barely partially stuck open, and so we may not have been able to feel too much vacuum. So this method is not foolproof, but it is another way that you can check without having a scan tool. And then obviously because you're unplugging it with the vehicle running, it should set a circuit code, just like we set a circuit code on here when I was testing for this one. So that kind of helps with your circuit integrity. So those are two ways you can check your circuit integrity, and we can check and see if this solenoid is working without the use of a scan tool. Now obviously you will need a scan tool to see if it sets that new code, so you'll need some kind of code reader, but you don't need a fancy $1,000 one. You could do that with a $30 scan tool, or code reader I should say. So in a pinch, that's what I would do if I only had a $30 code reader, didn't have all this equipment. That's exactly how I would go about diagnosing this. And obviously these methods aren't foolproof, but in a pinch it could help. And if you weren't sure what I was doing with the test light, I'll go over it real quick. For this solenoid to work, if you can see in there, there's just 2 pins, and so it just needs a power and a ground, and that'll energize the solenoid. And so what we want to do is take this out of the equation. So we'll remove it or unplug it, And we're going to take the test light, and it's the same thing. It needs a power and a ground, and it will energize the light. And then what's nice about a test light, it doesn't matter which way I put it. I could put power here and ground here, or vice versa. It's not going to matter. And so I'm just taking this test light and using it in place of the solenoid to see if our circuit works. And that's all I was doing. And then I just used, because you can see these don't adapt well to the plug that was in there, I used the AES Wave test kit to adapt to my test light. It just makes it a little bit easier, and it's definitely easier to film. And if you're curious about the duty control percentages that you saw on the scan tool, 10, 20, 30, 40%, basically, you know, on a 2-wire solenoid, you either have on or you have off. But as a way to control how much this is on or off, instead of just being fully on and fully off, the computer will turn it on just for a little bit and then turn it off for a little bit. And turn it on and turn it off. So when you see, like, say 10%, what it's doing is it's turning it on 10%, and then for 90% it's turning it off. So 10% on, 90% off, 10% on, 90% off, and it just goes back and forth. And so, you know, I'll demonstrate it using a test light. So basically it's 10% on, 90 off, and so you wait, and then 10% on, then 90% off. And so when you look close, you'll be able to see the test light flicker, because the computer is obviously doing it really fast. It's doing it super fast, much faster than I'm demonstrating it here. But that's a way to control the solenoid so that we're not just fully opening it all the time. And to demonstrate it on a vehicle, I have the test light hooked to negative, so when we hit power, you can see it lights up. And so what the computer is doing is it's 10% on and then 90% off. Then 10% on and then 90% off. And it's doing it super fast, so when you look close, you'll see it flickering like that. And then obviously the greater the percentage on, the brighter this bulb is going to be. And it's the same thing for the solenoid. The more time the computer is turning it on, the greater that solenoid is opening up. And that's just a way for the computer to control it. Just like that. Now, I wasn't able to recreate the long crank time, but that's definitely one of the symptoms of a bad purge valve. So I think it's related, but there's always a possibility it's not, and I'll let the owner know that. Well, there you go. Hope you enjoyed how I troubleshoot and replace a purge solenoid on these 6-cylinder Camaros. And as always, if the video helped you out or you liked it, make sure to give it a thumbs up. Thanks for watching.